Hey everyone.
Good morning, Lewis.
Hi, Luis.
Good morning.
Good morning, Louis.
Just wait a little bit more individuals start before we get in. All right, one more minute and we'll get started. Okay, it is now 5 minutes after the hour, so thank you all for joining us, for those who were able to join today. And again, this is the sixth week of the course, so now this is coming to an end. So I hope everyone had an enjoyable time understanding a little bit more about Gen AI, be able to now talk a bit more of a technical sense with other individuals when they say RAG, when they say agents, when they say tokens chunking, understanding a little bit more how the transformers work. You now have that sort of in your tool case of being able to have those types of conversations and be able to understand and be able to apply them in your workday and your everyday, if that's where we're looking at as well, right? Even at a high level in terms of in a business aspect, understanding how to apply them, how to actually get the gains and understanding of that part. So today is more understanding more of your capstone project, really working towards something that you really wanted to build and understand, get to know a little bit deeper in yourselves. So what we can do is maybe put your hand up in the Zoom chat for those who have something they want to present and share, and then we'll go through each one one by one and be able to celebrate all the hard work that you've been able to put into your project. So we can start doing that. Okay, so I think we just need permissions for someone if they want to share the screen just to be added in.
I have already given.
Okay, perfect, great.
Yeah.
All right. So let's see here. Is there a way to put your hand up in here? So I'm sure there's a. I think it. Yeah, I think you have to put a thumbs up there. I don't think there is a. I don't think there's a hands up here on this side. So yeah, just do a thumbs up in the chat, and then we can quickly just go one by one in that way instead. Okay. All right. So maybe Swami, do you want to go first and be able to present to us what you've been able to do?
Yeah, sure. Okay, let me share my screen. So primarily, this is a RAG for websites. The idea is given any website, this RAG can parse the content, and then you can ask questions in that. So for this, I have used Olama server. The Olama server it lets us download language model into our local system. That way, our data does not go across. Let's say in our office, if you want to deal with sensitive info and all, this model works. And then I used LangChain, of course, to communicate with that. And then some embedding vector DB. And also I use Gradio for the user interface, actually. And then one more thing I did was I deployed this through Hugging Face, actually. I spent more time there. So then I have something working with Hugging Face as well. So I can just talk about it, how I did. And then if anyone just, by the time Hugging Face, I had different interpretation. Then after trying to use it, then I realized, okay, this is it. I can't say I know more, but at least I know how, at least I was able to use Hugging Face to deploy this one. So then
Awesome.
if you have time, I can go through the notebook, or I can just show the demo, whatever works.
Yeah, maybe just quickly walk us through the notebooks so people
Yeah, sure.
can learn a little
Yeah.
bit and go
So
from
then
there.
we can run while walking. So then this is in Google Colab. So then I am creating a Google Colab extern. And then here I am asked in the extern, downloading the Colab extern. And then here our idea is, since we are running Olama in our local server, here are the steps. So to download it, here is a curl command, and then we pass that to the shell, this install.sh. So it installs Olama server locally. And then once it is installed, then we are pulling large language model and then this embed text utility. So it is all it is saying is, okay, run these commands. So this step is to download and install the server. And then it takes around a few seconds. So while it's doing it, I can just show a demo. So I deployed same app through Hugging Face. And then there is a website called NG Softing, actually. So in that website, I asked this question. And then for some reason, I am running this Llama server locally. And then it takes almost around a minute to parse the whole thing. Maybe every time it is kind of downloading the whole website content and trying to understand this. For example, this is all the question I have already asked, actually, and I can ask. Then again, it shows, okay, it needs around 100 seconds. So we can come back to here. Yeah, this is downloading the Llama server. And
For me, what do you mean by Llama server? Is it just
yeah.
the LLM that's downloading, or is there more to it?
Llama server it lets us download an LLM. So with that server, you can download Llama 3, and then there is something at Gemma, I think I don't, not. So it lets us download these LLMs in our local and run those. So like you are hosting an LLM in your local, where you only have access to. And then let's say your team or whoever company can use that LLM for interacting securely without going data to internet. Maybe Luis can add more.
Yeah, so there's different ways you can run an LM. So we're using APIs simply because it's you don't have to have a big computer or the newest graphics cards to run it. So in Hugging Face, he was showing you can download all these open source models, but there's some of them are large, a 405B. You'd probably need more than 1.5 terabytes of RAM to be able to run those. There's smaller models which only need 100 gigs to 200 gigs. So it's really dependent on how much power your computer has, or you can do something like this. What he's showing you is using a smaller model that's going to pull in from Llama 3. What this does is then it quantizes the model to be a bit smaller, so it's able to run faster on the local. So right now, if you can see right now, it's trying to download all the different models from the server website into his Google Colab. So as that's going down, maybe just walk us through the code rather than running the whole code itself. But if you were to say the main parts of,
Yeah. So now there is a command to start the server and then pull these language models. And then first time it failed because server wasn't ready yet. Maybe if I had added a sleep command, something in the middle, that would help.
Mhm.
But one way is I can rerun it. I rerun the command. Now this time the command pull that model succeeded. Now to interact with the LLM, we need LangChain. So now installing LangChain.
So for those who are curious, so if you go back to, or if you go up to that top box that you had there, sorry, on the right side, on the bottom, so where it says 4.7 gigabytes on that right side, um, in your
Yes, output. Yeah.
your outputs. So what happens are these models are sharded. So these models are usually when you download them, they come in pieces. They don't come in one large file simply because they're just too big. For example, the model that he downloaded shows it's 5, 10, 15, 20, 25 gigs of memory that he's downloaded right into the Google Colab server to be able to answer. So this is what he's using. As you can see, that's 25 gigs. So if you have a computer that has at least, you need at least probably 50, 60 gigs of vCPU for it to run efficiently with that. But what Ollama does, he's showing here, Ollama actually understands the architecture of a model Llama 3 and it's able to break down and look at smaller quantization bits of that model. So Ollama is to help Llama models run faster locally. So that's sort of understanding a little bit more of what he's up to.
So now I'm importing this Llama server with a model. I'm saying I want this model Llama 3. Now, in the to-that model, I am just invoking to test it. I am just invoking the command. How far is sun from there? This base model is language model, right? So it has some basic capabilities, though it does not know anything about our website yet, but it has its native capabilities with all the learning it has. So it says now it is 93 million miles and all. So now we have the model there. And then to that model, now we need to hook up our website. We need to tell the model, give the contents of our website to the model, and then we can ask questions. And then I have some library conflicts. Then so I had to uninstall TensorFlow to use these actually. I may not have to do it, but I tried a few ways. This way, it always worked for me. Then I'm going with that. And then I install these.
Just to pause there so people can understand. So because Google Colabs comes in preloaded with packages already installed, this is why he ran into a conflict of trying to run something and be saying, sorry, I can't run this. So in order to remove that conflict, he removed that package and is reinstalling it to the version he needs.
So now I'm installing whatever I need. So while it is installing, so now Gradio is something where, we did some chart examples where Luis has shown us chart examples where we were asking commands in like a terminal model. But what if you need some kind of basic HTML or something? Gradio provides that for us. And then Beautiful Soup is for crawling, web crawling. and then text splitter is for splitting the text, and then we have one for web basic loader, and then chroma db, and then embeddings to give to the language model. So we can walk through that. Let me run this once, and then we can do that. And now, yeah, after running this, it created this. And also Gradio came with this actually. Now I have this interface as well, where this is also live. I can ask questions here as well. This is same as that one. So then I can post a question here, and then while it is running, we can go through the code. So let's see how long it takes. And oh, it came back quickly. Google Colab is faster. So so if I go through this website, then this is the phone number. Like that, we can ask various questions in that. Let me see what the Hugging Face failed. I don't know why. Maybe my server died. I don't know. So then, so then now we can go. So then here, go ahead.
So maybe you can walk us through about how you loaded that website for it to know, maybe a little bit of how the chunking strategy, why you chose that chunk, and did you play with it, and maybe just walk through your learnings.
Perfect. So this is the URL, and then we are saying we are loading that URL through crawler, and then we are loading that URL response through docs. And then, no, this chunk size, I got some example from internet. I didn't get chance to play with it at all. Actually, maybe I should have done it. So now we are giving chunk size as 1000, chunk overlap 200. And then we are using this splitter to split the docs. And then we are using Ollama embeddings. And then embeddings is just to split the content, right, Luis?
So the embeddings is vectorizing vectorizing your chunks to put it to your vector store.
And then maybe I will try to explain in my own terms. Please correct me if I'm wrong. So vectorizing helps us to rank different things. It has, for example, let's say we have, let's say stocks, and let's say there is symbol Goog. Then vectorizing associates those together with some value. Like that, they have multiple dimensions of vectorizing, not just one dimension they vectorize. They vectorize in different contexts, so that they can relate. If I ask phone number, they understand, okay, this company's phone number they're asking. If they ask service, so to do that association, this vectorization helps.
So in order to do a RAG, what it does is when you have a question, anything like that, and you're trying to realize from your RAG which one's the best results. We learned that I think the second last fourth week, we learned a little bit more about those embeddings and what different ones have. So what it does is it converts everything from that website into different chunks that have different numerical values based off that rate. So when you ask a query, what's going to do is converts your question first into an embedding as well. Then it looks at the embeddings that are in your RAGs and try to do a similarity search based off semantic or keyword search off that vectorizing, and then ranks them to determine which one is the best one for your top answer. So that's using the nomic embedded text as your main embedding model for your websites on that section.
So then for embedded store, once embedding is done, we need to store in some DB. So Chroma is for that actually. So
correct.
From these documents, we are using Chroma DB to store that vector data. Now I'm just creating a function called Ollama LLM, where it takes a question and the context. And I think context, it remembers whatever the previous question was asked. So then here is a prompt, and then Ollama has something called a chart, where you can say, this is the model I want to ask this model, and this is the message I'm giving it actually. So this prompt we are passing to this chat method, and then the response is being written here as part of this function. And then I think this is a RAG setup. So this is from the vector store. We had that RAG handler. And then I'm creating a function called RAG chain. It takes question as a parameter. Then it retrieves, it invokes that rag with that question, and then whatever the response it comes, it passes back. And then let me go through. So there is something called Gradio. With Gradio, I'm creating an interface actually. And then it is driven by this question, rag chain question. And then input is, so it gives us the flexibility. Like for example, enter your question here, right? This is this text I'm filling. And then output is the text. And then title, I can say title, whatever title I want, rag with LLM for the website. And then description, here is a description. So the Gradio gives that flexibility. And then now we hooked up Gradio with LLM through LangChain. Yeah, Luis, if you want to add anything for that.
No, that's great. Fantastic work. Thanks, Swami. That's a great use case. So looking at whatever website you need to have, be able to put that URL in, be able to grab it and do RAG on it. And what's great about this RAG is that it helps reduce hallucination. So you typically have a retriever that may go out, pull website information in, but a RAG will help reduce hallucination rather than just doing a typical agent that way. So awesome work.
Thank you.
Last
So
question. What is this Gradio used for? I did not understand that.
graphics interface. For example, this interface we have, right?
Oh, UI, the UI.
Yeah, exactly. Right.
Oh, okay, okay,
This
okay.
is given by Gradio for us. So then now this class Gradio, this is Gradio import dot interface. We are mentioning all this title, description, all these are given.
Got it.
And I tried even with slick deals as well. And then ask, okay, what are top deals? It was able to give something, but it took a long time to process slick deals actually. So yeah. So then, yeah, now I have multiple ways. I can run here and I can run through Gradio, but then this is Hugging Face. I had to do differently. This is all different path actually. Hugging Face actually. Luis, shall I talk about just high level Hugging Face too?
Yeah, just take one minute, take a minute before, yeah.
Okay, perfect then. So Hugging Face actually, yesterday only I started using this actually. With Hugging Face, all it needs is a Python program and then your required libraries. And then it gives a container for us actually. So in Hugging Face, yeah. So in Hugging Face, this I created a repo called Swami VSF Depot. And then if I go to this repo, just I created it. Initially I didn't know anything about it. I uploaded this Python notebook. It doesn't need it. So the Python content from the program in this notebook, we need to call it as an app, and the requirement.txt will just tell what are the libraries you need. And then when you have this app, when the moment you check in, it tries to create a container for us with this app. Just if you want to give an example, what I can do is I can just edit this, and then I can just enter some comment. And then I can commit. Once I commits, then and then I go here. Then now it is building the code with the Python code. I think this is from the previous run, building the Python code. And then what it is, I think its build is queued. Yesterday night it was free, but now it is queued. And then once build is done, oh yeah, then it will start the container for us, Docker container or container for us, so that your application can be run here. And then some interesting facts is now I have to download Llama in my local machine, right? So then how Hugging Face can interact with Llama if I have download in my local, right? There is some library called ngrok. With the ngrok, Llama server runs on default port 11434. I have set up ngrok such that the port ngrok localhost 11434 becomes an externally accessible URL. And then that URL I gave in my Python file. I can show that URL to you. So when Llama embeddings, I gave this is the server URL, because this Llama server, which is running in my local with ngrok, it is available from outside. That is one interesting fact. It took a long time for me to set up that. It was giving 403 errors, access errors, and all that stuff. And then next interesting, the first, Yeah, running some Rama server locally, and then installing, and then by setting this up, then it is available. And then we need to run a Hugging Face container. And then these are some examples from Hugging Face. Yesterday I ran actually. See, this is from Hugging Face. And primarily, actually, Hugging Face main purpose is there are already pre-defined models created by users. It lets us reuse and containers and all that stuff over Hugging Face.
Awesome. Awesome job. Thanks so much, Swami. Thanks for putting that much effort in. Do you feel like you learned a lot more working on with this and bringing it to production to productionized state?
Yeah, no, actually, thanks to you. It was all a black box to begin with, and then you made much easier. And also, I would like to say later, but thanks to VSF organizers as well. They took time to bring this up, and this is really thank you. So yeah,
Awesome.
I'll stop sharing.
Perfect. Thanks so much, Swami. So again, I didn't expect everyone to go down this level. So Swami just really set the bar really high in terms of having a good Hugging Face and throwing up a UI. So he went above and beyond. So I don't expect that from everyone else. So don't be shy. Like, oh no, I didn't do as much as Swami did. So if you just have a notebook and you just have chat, like share that as well, right? Like, again, all this is just a learning experience and just developing a quick chat bot or something that you'd be able to learn yourself as well. So good job. So I'm going to just give you like a round of applause for the work you've done. And then we'll go to our next person. So I think Shaila, you were next in terms of your thumbs up in there.
Yes, Louis. Okay, let me share my screen.
Awesome.
So, yeah. Just a small presentation. This is what my Capstone project is. So the problem is, 1 second. Yeah, what I wanted to do this Sevak bot is for a high schooler who are always on a quest to find the dream college and the major that they are passionate about. And, they're always like curious to know what careers that their passion would, uh, what kind of careers that are there in the market for their interest and the passion. So the solution is a bot where it helps the students to clarify their questions regarding college admissions process, their admission process, finding their dream college fit their personality, finding areas, job opportunities, and the jobs that pays well. I think right now a lot of kids are in that mode of, finding the job that pays well with the uh, way that, right now the job market is. For this, I have used Tavily API to search data from few websites, used Gradio to implement UI, and my model is Gemini 1.5 Flash. This is that. And now let me open the. This is I used the Google Colab. This is already ran. So let's do this. So you can ask few questions, and this chatbot will give you some answers that clarifies your question. Like we can ask some simple, start off with some simple questions like this. Let's see what it gives. Okay, so it gives all the careers for the music majors, and you can ask more about it. It's kind of helping the students to think more about what the majors that they're interested in, so that they can have a better success rate and they can find their real passion and interest that they would like to pursue in the college. So it could be yeah, it could be everything related to the education and mainly for the high schoolers and for college process thing. Like, let's try something else here. So it also gives, it gets the information from a couple of websites and gives you all the information from different sites, and it helps them to have in one place and better understanding what it is, and they can decide well based on the information that it provides all at one place. So this is the project it is. And yeah, any questions or anything that you would like to talk about?
That's amazing. Great job. So you built a chatbot, be able to answer questions. So maybe we can explain a little bit to the team about what is Tavily, how it worked in your code, and we can share a little bit about so they can learn a little bit more about that.
Sure, sure. So yeah, Tavily is it's a API UI search where it takes, it does the work, the search, it provides the response for you, everything. You need to provide where it needs to look for. So here I asked, I have given few sites that it has to look for, and it gives me it looks for it and it gives me the comprehensive result as an AI response. And I also given few context for it to this context, this instructions, this communication style is very much crucial for this. Without this, you'll get also vague answers that yeah. So these things are important to give. That is about Tavily, and here is these are all the common API and before that I had this chat history and all. I'm saving the chat history and also this, uh, then message and all. Yeah, so here is the query that it's getting chat history message. Here is the response and all. The Gradio, using it as a UI thing. It's using it's taking the query message history, sending it, and it's displaying it through the text boxes and all. Yes.
Okay, amazing.
Thank you. Thank you, Yes.
Awesome. So what was the biggest thing you learned from doing this project? I would say just to give a heads up.
Biggest thing is this is not like your regular programming code. This is more of instructions that you give to the model. So
No es que tengas razón.
yeah, so that has equal importance to the coding as well. Like coding is like, how do you want to use your model? How do you want to do your chunking, ranking, embedding and all. But even giving instruction is also have an equal importance, because that's the way the model knows what all to use, what is instructions, like, be friendly. If you don't give this friendly, it just gives a random answers. And if you just include that be friendly, approachable, encouraging, that itself gives a different tone and style. So yeah, it's a different way of approaching to the model, this kind of AI coding. And for me, it's a very new topic, new area to explore, and it's been a great journey. Thanks for everything, Luis, and thanks for VSF tech team. Yeah, it's a good start for me, and I really enjoyed the sessions.
Shaila, good project, good concept. And also, how does it know if something is trusted source?
Yeah, I didn't take that measure, but I did give it to the instructions. Like I did mention here.
Like you mentioned, I do only provide information from, yeah.
Yeah, that are the sites, and also I think I have mentioned in the instructions.
Yeah, I see in your instructions. Yeah.
Right? Yeah, that's the way.
Second line.
That's the way I try to guardrail it, or
No, I know. The question like, how does it know if it is trusted or not? Even the Tavli.
See, I'm asking. Oh, Tavily goes only for these sites, and I know these sites are trusted sites.
I see. See, in the sense, so in your instructions, you are asking as a context, right? So that means if we are already giving the sites, then do we need to
Hmm?
tell it to go to trusted sites, right? Or you are saying that don't go anywhere else other than these domains?
Yes, that's the
Okay.
domain suggestion.
Okay, gotcha. Okay.
Yeah, so just a little bit more. So if you guys are more interested, visit Tavily. Tavily is sort of it searches the internet, but it's not your typical search. It's sort of verified by humans in the loop of what information needs to be extracted, how it's extracting informations. There's sort of advanced ways. So if you can see there, she did search depth advanced, and she's actually included which domains what it has as well. So if she were to remove a couple of those and said only pull that information in there, and you'll probably get that there is no information because it's not looking in those specific domains. So this is something that you guys can look at, maybe you'll review as well as you go through this. But this is a great example how to make sure you only are looking at on the particular sites that you want.
It's also scraping through all these websites, right? Basically scraping through the websites like, similar to chatbot what Swami presented. Is that right understanding, Shaila?
Yes, so so this website, instead of using DuckDB to go and sorry the search step before to go and pull their website out, Tavily does this for you. So Tavily will then you will send the search to Tavily. Tavily will then go grab it, re-rank it, and do all that fun stuff with the backend for you, and then give it back to your LLM to review.
Okay.
You guys can try it out. Tavily gives 1,000 requests per month for free. So feel free to try out Tavily and see how that can help.
And does Tavily do the recursive searches? For example, all the pages in a given domain?
So yeah, so Tavily is as simple as similar as Google search. Like you type in like what is like who is like think of one example like who is Leo Messi, right? It's gonna look up the top website pages that come up with those top links and then give you the information from those pages itself. But for it to go to every single page on a single website, that's something that'll have to be a different use case. For Tavily wouldn't be the best one for that one. Okay, awesome. Thanks so much, Riley. You did a lot of work on this and you finally got it working and you didn't get into any runtime errors, right?
Sorry, Luis.
You didn't run into any errors, right? Like the runtime API errors or
Not with runtime API errors, but while I tried a different, not this code, but a different code, but with that it wasn't giving me the final answers. So like Swami did splitting and all. So I had to do that and get only the response. That was this there. But yeah, with this code, I didn't face that one. But yeah, through the working trying to work this project, I did face that one thing, but yeah. Otherwise, I mean, collab is so easy to work. You give your what do you want, it gives you the code. So that made my work little bit convenient and easy. But yeah,
Awesome. Awesome.
thanks, Luis, for everything.
No worries. Okay, is anyone else? I don't put a thumbs up in the chat for if anyone has someone like they like to present as well.
Yeah, I can present, like, but I'm not prepared. If it's okay to unprepared presentation.
Yeah, that's fine. You just yeah.
Just give me 1 second. Uh, Basically, like, what I did is like this is basically it takes a audio file, it transforms and transcribes using AWS, and then after that it takes the conversation text and then you run on the LLM asking the questions on the top of that. So this is the code base like I did some time back. So basically, uh, I use Claude. Uh, I did several times, like, sometimes I give the text like this and then ask the questions like, okay, what are the action items in each of the comment? Like these are the based on a comment. What are the key points update on the from each comment? What are the key takeaways like this? And then I ran this through the and then got the response. And then this is the response. Yeah, I ran several times with it, several different questions and the transcribes. So you can see here, like, let me see, where was the response? Yeah, so if you see action items, strengthen the draft rule to maximize the climate benefits. Do not allow polluting projects to qualify the clean air credits. Like this, these are the key points, various key points. What are the takeaways? And then like, okay, who is the, what are the tasks out of these comments? Who should do that?
Amazing. Awesome.
Yeah.
And are you using AWS for the audio transcriptions? They're using their model?
Yeah, I think this is the one which, no, yeah, so this is the one I use for the transcribe. But this is a different one. Like, I took
Yeah.
some travel conversation MP3 and then transcribed that using the transcript. And then like after the transcribe, like actually the logic is like you won't get in a conversational one after the other. You have to reconstruct that actual conversation. So that's where this logic comes in. And then after that, I saved it to the bucket.
Okay. Awesome.
So I can show some of the transcribed. Just 1 second. Yeah. Yeah, so the transcripts would be something like this. Yeah, so it'll give me like the speaker 1, speaker 0, and then speaker 1. What was the entire conversation?
Also, it knows speakers by audio tone.
Yeah,
Oh, that's cool. That's really cool.
yeah.
Amazing. Yeah, it's I think one of the key features in AWS, they have the audio listening and transcribing package that they have. Usually during call centers, I work with a lot of different companies that do call center intent, call center information as well. They use the AWS packages to help understand and able to navigate users interactions.
Yeah, this is another output for the like next steps, takeaways.
Awesome, awesome, great work. So remember, LLMs are not simply just text. LLMs are now something called multimodals, in which they can understand text, images, and audio, as we just saw right now. So great work. Okay.
I did rag also on the collab sometime back, but I'm not ready to prepare show that.
And no worries. No, awesome job. Thanks so much, Rajan. I hope you were able to learn and apply a little bit more information you from these courses to your future projects.
We are waiting for the next set of training.
Okay. Anyone else? Okay. Just, if that's not it, so just everyone we'll take a quick 5-minute break. I'll be able to show one little last demo for myself to go into these things, and then we'll continue from there. All right, everyone, we'll continue back in about 5 minutes. So I think at 53, we'll go from there. Okay, just one second. All right, everyone. Okay, we are back. Does anyone else have one to present before we go to our last thing? Okay, awesome. So what I'll do is do my last one. I was working on a small project as well, very similar. So there's many things you can do with feature classes and more advanced things. So I'm going to show you guys an example of what you can do using multimodals. Again, as we saw before, we're using AWS, but what would be one if we were to create your own using OpenAI, using other types of informations and go from there. So this is something that I was working on myself, just for a fun project of how can you do something that's real time that you can sort of do a text-to-speech translation. So if someone were to say something in English and you need to translate this in sort of real time, what could you do in order to do that? So there's other ways you can do it, simply just using OpenAI's APIs, and it would cost you a lot of money. I was trying to look at different ways of doing this. So I did a combination of using Google Cloud's text-to-speech client. So he was using his text-to-speech on terms of AWS, but I used the Google Cloud one simply because it's a little bit cheaper to try this. You simply just define your class of you're recording the audio, waiting till someone stops speaking. How we're going to transcribe the audio. So using the transcriptions, we're going to use OpenAI's Whisper API. Using that Whisper API, we then translate it, right? So you give your prompt to the model, similar as we're doing with the GenAI products of the system. You're a professional translator in translating English to Spanish, and you'll translate the following from English text into a Spanish text. So pretty much what we're going to be doing is someone's going to be speaking in English. It's going to transcribe it really fast in real time using GPT-4o Mini to sort of translate the English text, that sort of text to speech, read the text, translate it to the following language that we prompted to, and then give that response back to me. And in order to read it, I'm going to use the text to speech, Google's pathway, what they're doing, just using a neutral voice, standard, and have it speak back to me that. So going back to what the project I was doing is having the audio that's being spoken about using Google's text-to-speech client, right? So whatever I'm talking about sort of needs to be transcribed first. So in order to transcribe that audio, we are using that Whisper file, right? We need to use something from OpenAI that does transcribes the audio data first. Then after we transcribe the data, we need to translate it, which is the second step of translating that text to that language. And then finally, you have text to speech, which I'm using Google Cloud text to speech feature, which makes it really fast. You can use any other text to speech if you have something in Windows, you have something like that, but I was just trying to do something that that's able to understand accents and different things like that. Then something that plays the audio and then plays back the audio. So this is something that probably took me maybe 3-4 hours just to create, just to try something out. But how this would look like if I were to run this. So if I were to run this, I would, let's see, because I have the mic open on Zoom, but let's see if it works this way. Hi VSF Club, this is a test. Okay, so this one is not working because I have to put a client in here. 1 second. I just didn't want to put my client shown my credentials and this one here. I have to put my credentials back. Okay, I'll bring it back to the screen. Okay. Hi VSF Club. This is a test.
Esto es una prueba.
So as you can see here, I put in some times in here saying transcribe text. This is a test. It takes about 30 seconds to translate that. It tells me the transcription time for this, able to tell me how long it took to translate that text, then do audio playback of what that translated text would be and pull it back within 2.10 seconds. So, and it's because we're on Zoom right now as well, and my mic's sort of open. So it's not be able to hear everything properly because we're using the mics for this and for that part as well. But it's sort of a quick project I was working on, just to show you what are the different ways to be innovative with these LLMs and to really design and build these new products out, right? And that's really what I want to help and sort of inspire you guys to say that there's more ways to do it than just do text. You can do audio, you can do images, you can do many things with multimodal models. And I'm really proud of the people who've actually put in the work and now those people may be shy showing their work as well. I know you've been working on your own stuff and your own rags. And just remember, there's lots of things in this field. We just went through the basics. But like example, these are more an advanced, like what I'm showing you is more an advanced way of now trying to use multimodal models rather than just text, but now how we can use audio, how can we use images. When we do rags, you can use a multimodal LLM to consume your PDFs or consume websites that you don't need to use other things that may not be as accurate, right? So again, just something quick, I just want to show the team of how that would look like. All right, I think we're coming close to the hour. So if no one else has anything they want to present, I'll just give a last minute one minute to see if anyone else wants to present anything. Okay.
I'm going to take a minute. Hey everyone, those who don't know me, I'm Srinath from VSF Tech Club Organizers Group. Thank you for attending this. We've got lots of questions about, hey, what is the future? What is the next step? That's in so many people's mind. Those who didn't make it to the cut of 40 people, they are the ones who are pounding, who are knocking our door, asking for, hey, can we have a repeat of this? Or can we have a enhanced version of this? There are many questions that we are receiving. So we are going to take a step back and think about all the questions that we have received. What is the appetite in various sections? And then we'll see what is the potential next step that we can take. But till then, yeah, hang in there and we will try to communicate as and when there is a change at our end. Thank you.
Great. Thanks so much, Srinath. So exactly what you're saying, there might be tons of questions, what's next, but well, I think that has to be a decision from the club and we'll go from there. So awesome. So again, thank you for everyone who joined this wonderful session and hope for all of you who are looking to be more curious, stay curious. There's lots of information out there. There's a lot of things on YouTube. There's lots of things on Kaggle. There's a lot of things on different ways of really getting deeper and exploring and understanding what can really be done in these Gen AI forums. So for sure, welcome. We thank you everyone for spending that time with me and hope you enjoyed your Saturdays. So maybe we'll see you guys soon.
Hey, Luis, thanks for taking the time, your valuable time over the weekends, spending with us. This has been very helpful. Thank you very much.
Awesome. Thanks.
Thank you, Lewis.
Thank you, Luis.
Yeah, thank you, Luis. Actually, your the course structure and the way you brought us over was very cool. Actually, yeah. And also, can you share your notebooks, like whatever you did or anything interesting? Can you share somewhere for us?
Yeah, for sure, for sure. I'll share that after the class. I'll be able to share it for sure.
Thank you very much, Luis.
Awesome. Thanks for attending all those office hours.
Yes. Thank you.
Thanks, folks. Bye.
Bye.
Thank you, Luis. Thank you.
Thank you.